to part 2 of restoring top-of-funnel clarity in the AI era. Again, I'm Joe at Spadinabus. I've been helping my clients for over 20 years now with the adoption of innovations in the area of analytics, marketing technology, and digital, and help them move forward with greater confidence. So this is part 2. So if you haven't checked out part 1, check that out first. That's where I explain why I built what I built and why we're going to go into this demo. And it really has to do with the world of a VP of digital or some type of growth leader. Things really changing because of the widespread adoption of AI chatbots. So let's move into an overview of what I'll be covering in this video. Steps 1 through 4 are kind of technical, but important. They're usually where most of my clients get stuck, which is actually getting access to this data. And so I've been asked on many occasions to share how we do that. So what I'm going to walk through here is how I was able to capture that data for my website, so spadinabus.com. We're also going to be able to generate data through actually querying or making inquiries through ChatGPT and other chatbots. It can get technical. You can see I've got some of the underlying technologies that are down here. I'm including those. If you do want to skip ahead to step 5, this is where we get into more of a business context, and this is where we're using KNIME, which is the low-code data wrangling, modeling, and analytics solution. So that's where things get much more business-oriented. So before we jump into this, one disclaimer. I built this for myself. I built this for a professional services website that's relatively low volume. Some of the technology choices that I made aren't going to be good ones if you are in an environment where it is high volume of traffic. In my case, I wanted to have a solution that my resting cost, if I turn off the solution, if I'm not doing forensics, the resting cost should be 0. So that's why I did that. So I will call out some of those differences as we walk through as to why that might not be applicable for you, if you might want to swap out a different technology, especially if you're coming from a large enterprise. So with that disclaimer out of the way, let's jump into step 1, which is the edge origin, or in my case, this is where we're going to go into my web server and show how we're able to capture the AI traffic that's on there. Okay, so this is what the dashboard for spadinabus.com looks like. So how did I capture AI agent activity from here? So this is WordPress. It's a common web server, and I can install plugins on it. Totally not required, but I just thought it was a little prettier to use that. So I've got this plugin tool called WP Code, and here's some code that I have. So this runs every time a human or a non-human is visiting the site. And you can see it's capturing some attributes that should look pretty familiar if you're at all involved in the world of digital analytics. And some look really familiar, like the UA or user agent. This is where, if you're lucky, in many cases, an AI agent like ChatGPT, whether it's the crawler or the fetcher, is going to identify itself explicitly, but not always. So that's why we'll get into those nuances a bit later in this, and why a business oriented individual really should be responsible for making that determination of what's human, what's not, and what's the business value of understanding this activity. So this is written in this is PHP code. PHP code is server side. Okay, why do we care about that? Well, most web analytics, digital analytics, especially in a not so sophisticated environment, tends to be client side. So what does client side mean? This means we're talking about typically a human that's got a browser. The browser executes JavaScript, and that JavaScript, it's got tagging information, and there's this whole ecosystem of web tagging, digital tagging that's happening. And that's the way things work. And you get all these incredible insights. If it's a human and this is using a standard browser and that's happening. When it comes to AI agents, they don't always, and they in many cases they really don't play that game. So they are not executing JavaScript, and it becomes harder to capture their activity. So what's happening here is we are capturing the activity regardless of whether or not the JavaScript is being executed and the type of visitor. So this is the most raw possible form we can have of all the activity, and we can make that determination of what the activity is later in our process here. So it's raw and it's intentional, and this is the tricky part for many of our clients, where especially the more sophisticated the client, the bigger the enterprise, there are many steps along the process where things that don't look like humans tend to be discarded. And sometimes it happens right at the start here. So this is an example of me using PHP as a plugin here to capture this data. There's other ways of doing this. There's tools that are specifically designed for different applications and web servers to capture this. There are means of getting the same information by looking at logs, for example. So not the only method of doing this. So what else is going on here? You can see we are packaging up this information in a developer-friendly format, JSON in this case, which is still sort of human readable at this point, or still fairly human readable. And we are pushing it along to another service. And so this service, if you take a close look at the URL here, we've got Snowplow in the name. So Snowplow is a pretty common technology you'll find data engineers using, people that are administrating warehouses, data lakes, things like that. But this is just me. This is just Joe at Spadina. So I went with an open source version of this that's compatible. It's called Open Snowcat Cloud. And we will go there now as we'll move into step 2, which is ingestion. And I'll tell you a little bit more about that. Okay, so we're here in step 2, ingestion. So it's time to start collecting this data in a scalable, high throughput way. As I mentioned, Snowplow is really common here, but I opted for Open Snowcat in my case here. So my website is hosted on AWS, so SpadinaBus.com lives there. So for me to host Open Snowcat on AWS as well made sense. So I had a few choices around how to do that. I opted for a service from AWS called Elastic Container Service, or ECS. Why did I do that? Main reason was that, as I was saying, I wanted an ability to be able to turn the service off and have a very low cost at rest. So this is what the off button looks like. Its desired task is at 0. So we're going to go ahead and turn that on. I'm going to force a new deployment here. Other reason I did this is if you look at this part of my deployment option, there's many deployment options. I wanted to use Fargate Spot, which basically is the low-cost compute tier, where if AWS wants to take away my collector for a bit and service has to go down, that's fine by me in my situation here. So let's turn that on, and we'll fire that up. And through the magic of editing, I'm just going to pause here and come back once that starts. It takes about a minute or so. Okay, we're back, and our collector service is now running. So let's generate some events for this. Right now, this collector is grabbing anything that's happening on SpadinaBus.com. I know there's some health checks, and there could be some organic traffic that's going on there, but we're interested in AI agents. So let's generate some AI agent activity. So if I browse over here to ChatGPT, I might ask something like, who is the owner and most senior consultant at SpadinaBus.com? So at this point, ChatGPT is initiating a server-side call, It's going to the website to confirm that information, and it's generating those logs for us. So where did they go? Um, so this service, ECS, is really just the collector. It's that high throughput service for capturing that activity. In my case, what I used is the SQS, or simple queue service from AWS. And lo and behold, here we have 11 messages. So a lot of these are health check messages and other activity on the site, plus the ChatGPT call that I just made. This is part of the architecture that if you're in an enterprise or any environment where you've got kind of a commercial level volume of activity on the website, you probably don't want to use SQS. For me, it's great because it's serverless and it can handle these low volumes, and I can kind of decouple and have that off button like I mentioned. But in your case, you'd want to be looking at some type of streaming technology like Kinesis, Kafka, or other services like that that you've used, which Open Snowcat Cloud and Snowplow are happy to use at the collection layer, and also at the next step, which is the enrichment layer. So let's navigate there now and turn on our enrichment layer and see if we can see some of this activity showing up. Okay, so we've taken a look at the collection. We looked briefly at buffering with SQS, and now we're into step 4, the transformation and persistence. In an enterprise environment, this would probably still be Snowplow or Open Snowcat Cloud. In my case, because of my choice to use SQS and the simplicity of what I was trying to do here, I opted for a solution called Bento. And so what we're going to do now is we're going to fire up Bento in the same way that we did with our collection service. So again, Bento is running with an ECS. We just need to fire it up here. Same sort of concept as the collector. And so I'm going to set this desired task to 1. Again, I'm using spot instances. So let's wait for that to fire up. I'm going to again use the magic of editing here and save you the minute or so. Okay, our enrichment service is now up, which is actually Bento in this case. Normally it's a whole extension or secondary module of Snowplow or Open Snowcat. It's normally doing some different transformations and things, but that's a good case if you know exactly what it is that you'd like to transform. In our case here, the AI agents, their behavior, what they're doing, it's changing week by week. And so we're still not really in a position where we're confident enough to exclude certain types of data. And so for that reason, what I've set up here is to, again, more or less send the raw format, but it's a little different because of the type of formats that we expect for transmission with these types of technologies. So if we're successful here, if I switch over to my storage area of AWS S3, we should see some activity that's being recorded here. So you can see the folders organized by year, month, and sure enough, here we are on 23rd of January, and I'm starting to see activity here. So buried within here is the activity that we triggered through that fetch request with ChatGPT asking about who's the most senior consultant at Spadina. And at this particular moment, these files are not terribly human readable. So I'll show you what I mean by that. So I'm going to grab one example here. I'm not sure what this is, but I'll download that and we'll have a look together here. And I'll explain why it looks a little weird. So not terribly human readable. So what's going on here is with tools like Snowplow or Open Snowcat Cloud, it's common for them to be encoded into a format, in this case it's called Thrift, that's sufficient for transmission. And so it's not until we get to our last stage here of our pipeline, where we're really going to be able to look at this in a business context. So this was really about persisting that. So it's in storage, but it's not really human readable. We're not anywhere close to getting some insights. So we're now kind of at that final stage where we bring in KNIME, that low code visual analytics tool, where we can rapidly do a conversion of that thrift format to something that's human readable. And we can start to make some sense of that and move towards that bridge of insights and things that we want to get out of better understanding our AI agent traffic. Welcome to the fifth and final step of our data pipeline. If you are just joining us, what you missed in sections 1 through 4 here, really about ensuring that we're capturing and ingesting in a reliable way those often discarded or hard to capture AI agent logs and activity. This final step, we're taking a more business turn, and that solution is that part of the solution is based on a tool called KNIME. This is what KNIME looks like. It's a low-code visual solution that we picked because, hey, this is a moving target in a lot of respects. AI agents are changing all the time. We need a way to be able to change the way that we capture, label, and analyze this data without having to go back and adjust tons of lines of code, or maybe work with a centralized IT team that might have a longer lead time. So we're going to walk through each of these. These are color coded from left to right. That corresponds to things being more technical on the left, closer to like a data engineering type role. Something kind of in between here, in the silver color, with a bit of data science down here, and in the gold or yellow here, more business intelligence, a more pure business part of the solution here. So let's dive into each of these. Okay, we're taking a closer look now at the bronze area of this workflow. So this roughly corresponds to some more data engineering or data wrangling type activities here. So first thing we're doing is we're authenticating with our Amazon S3 service. So that's the cloud storage where we put our logs from step 1 through 4. Of course, other cloud storage platforms are supported, or analytics platforms that sit on top of that. So ones like Databricks, for example. So it's as simple as dragging those over to use those sources. What we're doing here in the Amazon S3 connector node, this is the root folder for where we've been storing all of our activity, all of our logs from step 1 through 4. I'm going to process everything that's in that root folder, but if I wanted to, you can see I'm able to browse the file system here. I could pick a specific month or day and only process that. From here, we're going to move on to taking care of that thrift format, making it a little more human readable. So we do that in a few steps. So first one is the thrift format is really only in a portion of the JSON object that we're reading here. It's under this raw payload area. So we're going to isolate that. We're going to isolate the timestamp. So this is when the fetching request was happening. That's the actual time. The rest of this information we can discard. We're not interested in that. This is where we're removing that thrift base 64 encoding, and we're converting it to UTF-8, which is the human readable character set. I'm removing some illegal characters here just so we don't mess up some subsequent steps. In fact, I'll run these as we go. And you can see down here each step in this lower part of the navigation, I'm able to see how our data is transforming at each step, and kind of gives me that confidence to keep moving. So you can see we're starting to get into some more human readable types of data here. So this final set of bronze nodes, we're still in this world of JSON objects, not always the best if I'm trying to do business intelligence or sometimes data science. And I want to have this in a more traditional table-friendly way. So the way I'm doing that is I'm going back to, again, this JSON path node. From here, you should start to see some attributes that look familiar from way back in step 1. So these are the same attributes that we had in WordPress that we were capturing there using our PHP code. And I'm using a point and click experience here to isolate each of those, label them, and ensure that they're going to move on into a row and column type format that's easier for me to work with in more business friendly steps. So that's what's happening here. And just kind of discarding some of the columns here. So that's the extent of our data wrangling and our kind of data engineering focused steps. You might say, well, how often are these going to change? Well, this is probably going to be the least changes and least frequently changing here. And so sometimes what you'd want to do is if you're using a tool like KNIME for collaborating with other individuals or teams, you might say, well, okay, this belongs in a different workflow that we're going to be connecting with and just see the results of that. So that's certainly one option. But KNIME does also have this concept of meta nodes and components where you're able to hide the complexity of those and kind of treat it as a black box. So just to quickly show you what that looks like, you could say, hey, all that complexity is stored here in bronze. This shouldn't need to change, but AI agents are changing quite frequently all the time. So there's a good chance that there might be new types of data or things that were discarded that suddenly become relevant, where you want to occasionally go back into this part of the solution and make those changes. Of course, you can do that in a way that's autonomous from a centralized IT team. That's one of the main benefits. So from here, we'll move on to our silver and our gold layers here. So we're now walking through the silver part of our workflow and a bit of our gold part of our workflow as well. There's 3 things that I'm going to walk through here on the silver side, which is kind of that in-between business and technical segmentation type of activities. First is some labeling of who our AI agents are. Second is our landing pages, labeling those, and then a bit of data science to show how we can discover what AI agents are doing and report back on those patterns. So let's take them one at a time here. Moving to the top of our silver workflow nodes here, we've got this area where we've got a number of expression nodes, and you can see each one is separated by the popular AI agent service. So let's see how that works. So if I open up the ChatGPT node, you can see it's a pretty straightforward condition we're looking for here. We're looking for this keyword, ChatGPT-user. Most of the time, ChatGPT is quite nice about self-identifying when it's doing a fetching request. At the time of recording, this was a fairly reliable way of capturing that. So that's all we need to look for. If there was some nuances to that or some complexity, we could add that here within this this node, or as I was explaining in the bronze areas, we can be using things like the component, the node, the meta node, or a workflow to kind of hide that complexity from this view here. So this allows us to label each of these, each of the AI agent activities. If we move over to the right here, this is where we're doing a more traditional business intelligence type of activity. And what looks familiar here is you can see we're working with just a bar chart. I can see there's 25 examples of a ChatGPT fetcher traffic, and we've got 4 for Claude. I don't need to use this to analyze this traffic. What I could also do at any point is if I wanted to, if I'm more comfortable in Excel, I can export there, or if there's another BI tool, we've got nodes that we can use to integrate that into your preferred BI tool as well. Okay, so let's move back over to the silver nodes here. In the middle, we've got a couple nodes that are working on labeling our traffic by the landing page or the intent of the AI agent. So we're not as concerned as to which specific AI agent the activity or the traffic is related to. It's more about what are they doing, what pages are they hitting. So to do that, I am using a slightly different node. It's similar to the expression node, just a little different. It's called a rule engine node. And the way this works is I'm able to write a bit of code that quickly allows me to label the traffic based on the incoming URL. So I take my URL field here. This is what the agent has visited, and I can use wildcards and things like statements to label these. So this is an example of me labeling the home. So just the spadinabus.com / as the home, and the other kind of top of the or major sections of my website. I'm labeling each of these here. I'm doing the same thing for the blog content on my site, looking for keywords and labeling those accordingly. And finally, AI agents, when they visit your site, they tend to like to traverse and just capture things that are really not that interesting from a business perspective. So a lot of plugins, a lot of templates, scripts. So at the bottom here is where I'm looking for those keywords and labeling those as kind of a system activity that doesn't have much value from a business analysis standpoint. So that's what I'm doing there. Once I've done that labeling, I can move over to the gold set of workflows and nodes here. And again, here's a different visualization, a bar chart. And you can see I've got the volume for each of the different landing pages that I have on my site here. So that's an example of, again, labeling the traffic to make it more meaningful, to get some business insights from it. The final thing I'm going to show you here on the silver layer is using a bit of data science to use, in this case, the K-means model in order to discover patterns that AI agents are creating when visiting the site. So if we're going to look for patterns in AI agents and how they're fetching from your site, we need to agree on what a session is. And unfortunately, the traditional definition of what a session is in a human context probably isn't much help for us. So in the digital analytics world, it was widely accepted that 30 minutes of activity equals a session for a human. Of course, in our case, we have AI agents. They're fetching, they're crawling. They are not behaving the same way. So we need different definitions, different way of measuring what it is a session is that's useful for us in terms of being able to react to their behavior. So let's look at a simple example of how we can define what a AI agent session is and how we can pipe that into our data science node, which in this case is the K-means node, an example of unsupervised learning in a cluster model. So how do we get ourselves ready to do that? So first thing is our precision is too high. When we brought in our data here with our pipeline, it's down to the millisecond. That's not going to help us do any type of meaningful binning of sessions or grouping together. So let's strip that out. Let's strip out the seconds and the milliseconds. Let's get us down to 1 minute precision. The next thing we need to do is we need to group by something meaningful that represents that AI agent. So let's use the IP address. We have those from our AI agents. Let's take the combination of that plus our session time, which is now up to the minute, and group those together. And that starts to become our definition of what a session is. Here, I'm just replacing null values or missing values with zeros because K-means likes it that way. And then I've got two more nodes that are doing a bit of math here. What are they doing? They are normalizing my data so that I can express our activity across these different landing pages or areas of intent as a percentage as opposed to absolute values, because that's just going to work better when it comes to graphing this and visualizing it. So on this one node, I'm calculating the total volume for that minute for that AI agent. And then I'm turning it into a percentage here by dividing it for each of those columns. This is where I'm creating a burst ID or a session ID. Just makes my graphs a little cleaner at the end. And finally, we're piping it into our K-means node. So here I'm asking for 3 clusters, and I am looking across all of these different categories, different landing pages, areas of intent. So once I've done that, what type of output could you expect, and start to build some insights around? In my case, here's what I'm seeing. So I've got 3 clusters that have come up, and you can see there's this top one here, which is cluster 2. I've got one in the middle here, and then I've got this pink one here, the bottom cluster one. What this could represent is, you can see that in the case of this middle cluster, in the darker kind of gray here, it's pretty systematic. So this is, if the AI agent is doing something with fetching, it's systematically hitting a number of pages in order to come to some recommendation. And that's distinct from the patterns that we see above and below. So in this case here at the bottom, it looks a lot more surgical. So there's specific parts of the page. Maybe it's pricing. Maybe it's trying to analyze something. So you can see these are ways of discovering patterns of what the AI agents are doing at a high level, without you explicitly having to say you're looking for something. So from here, you could be drilling down and analyzing these behaviors further. So that's just one final example of some data science that you can do here. Congratulations, you've made it to the end of this walkthrough. Hopefully this was helpful for you in terms of understanding both the challenges, but also the opportunities that are in front of us today with analyzing AI agent traffic. From here, some suggested next steps. I invite you to reach out to us at spadinabus.com/contact if you're ready to use some of these tools that I've shown in a tailored way for auditing your own environment to get those insights about what's happening on your site today. If KNIME is something that you found interesting, there's tons of resources at knime.com. The desktop version that I showed in this demonstration is entirely free, so you can download that and try it out for yourself. And finally, invite you to connect with me or follow me on LinkedIn to make sure you don't miss other content on this exciting topic. Until the next time.